Good morning to one another. Myself Ankitha. I am from CSCA. Today my subject is Basic Electrical and Electronics Engineering and my topic is Zener diode and its characteristics. First, introduction to Zener diodes. Zener diodes are special type of semiconductor diode designed to allow current to flow in the reverse direction when a specific voltage known as the Zener voltage is reached. They are widely used in voltage regulation applications due to their ability to maintain a constant output voltage. The Zener diode was invented by Clarence Zener in 1934 and has since become an essential component in electronics. Zener diode structure. A Zener diode is constructed similar to a standard diode with a PN junction formed by doping semiconductor materials. The key difference lies in the doping levels, which are high in Zener diodes to achieve a breakdown voltage at a low threshold. This unique design allows Zener diodes to operate effectively in the reverse breakdown region without being damaged. Working principle of a Zener diode. Zener diode operate primarily in the reverse breakdown region where they maintain a constant voltage across their terminals. When the reverse voltage exceeds the Zener voltage, the diode allows current to flow, stabilizing the voltage. This characteristic is exploited in voltage regulation circuits to protect sensitive components from voltage spikes. Zener voltage. The Zener voltage is the voltage at which Zener diode begins to conduct in reverse bias and is a critical parameter for its operation. Zener diodes are available in various Zener voltage rating, typically ranging from a few volts to several hundred volts. Selecting the appropriate Zener voltage for an application ensures effective voltage and protection. Characteristics curve. The IV characteristics curve of a Zener diode illustrates its behavior under different voltage conditions in both forward and reverse bias. In the forward region, the diode behaves like a standard diode, while in the reverse region it shows a sharp breakdown at the Zener voltage. The curve allows engineers to understand the operation limits and efficiency of the diode in circuit applications. Applications of Zener diodes. Zener diodes are widely used in voltage regulation circuits, providing stable voltage levels for electronic devices. They also serve in over voltage protection circuits, safeguarding sensitive components from voltage spikes. Additionally, Zener diodes can be found in signal clipping and waveform shaping applications, enhancing signal integrity. Advantages of Zener diodes. One significant advantage of Zener diode is their ability to provide a stable voltage over a wide range of load currents. They are also cost effective and readily available in various voltage ratings and power capacities. Furthermore, Zener diodes have a simple design, making them easy to integrate into circuits. Limitations of Zener diode. Despite their advantages, Zener diodes have limitations, including a relative low power rating, which can restrict their use in high power applications. They also exhibit temperature sensitivity, which can affect their performance, particularly in varying environmental conditions. Lastly, Zener diodes may not provide the best voltage regulation at very high currents, leading to performance deintegration. Zener diode characteristics over a graph. From graph we can clearly observe that on x-axis we have forward bias, on y-axis we have forward current, on above the axis and below the axis we have reverse current. From left to the graph we have reverse bias. On forward bias the current is slightly increasing, but on Reverse bias, the current divided into two parts. They are mainly avalanche breakdown and Zener breakdown. Zener diode versus regular diode. Unlike regular diodes, which are designed to conduct current primarily in one direction, Zener diode allows reverse current flow at a specific voltage. Regular diodes are typically used in rectification, while Zener diodes are focused on voltage regulation and protection. Understanding the differences between these two types of diodes is crucial for selecting the right component for an application. Conclusion: Zener diodes are essential components in modern electronics, providing reliable voltage regulation and protection. Their unique characteristics make them suitable for various applications, from power supplies to signal processing. A thorough understanding of Zener diodes and their operation is vital for engineers and designers in the field of electronics. Feel free to adapt or modify any part of this presentation as needed. Thank you.